Hello and welcome back to another video. So today's videos we're going to talk about blockchains and we're going to visualize the blockchains in an atomic level. Blockchain can feel abstract, but it's actually built on simple concept. We will build a blockchain from scratch, starting with a single piece of data and ending with a decentralized network. Okay. So at first we need to understand what is this hashing. So hashing means this is used in Bitcoin blockchains. It is a footprint of data. So what that means, for example, we can understand this with a real life example. What is the unique character or unique things about a person by which we can easily identify him or her? So that is the fingerprint, right? If we can find a fingerprint anywhere, then we can easily find that this fingerprint belongs to this person, right? So same thing, if I write my name, so this my data is generated as a hash of 64 character decimal, that is 256 bit. So this is not the compressed version or the encrypted versions of this input. The hash is actually the footprint. So this data means this hash, right? There are a few characters of this hashing. That means deterministic, means if you give the same input, it's always going to produce the same hash. For example, this my name is starting with the 19BA, right? If I again give my name, it's again starting with the 19BA. That means for single input, your hash is always going to be produce same hash, right? And it's one way that cannot be reversed the hash to find the input. So if you have a hash, you cannot generate the input data because it's not encryption and decryption. It's actually the footprint of your data. So this data means this hash, right? And collision resistance means it's near impossible to find two inputs with the same hash. Every unique individual has a unique hash, so it's impossible to have like two inputs with the same hash, right? And small changes in the input, that is a completely different hash. For example, if I write H, it's starting with the triple A, right? If I make it like cap H, so it's a completely different. It's not like there will be slightly change in the hash. There will be like a completely different hash. Okay. So the first thing is for a data, we are going to make a footprint of our data. But in blockchain, it's not only storing the hash, we are storing the real data and we are storing the footprint, that is the hash of the data. So if there is any manipulation in the data, so we can easily find out the hash, because if something changes in the data, your hash will be different. So we can understand this in the later part also. So let's understand about the block. So what is block? Block contains few things, that is a block number, nouns, data, and it will produce a hash. Okay, so right now you can notice that the background color is red and it's showing invalid. That means your block is unsigned and it's not valid. So what is a valid block? The valid block depends upon the protocol, and for a real blockchain in a Bitcoin, their protocol says that your hash should start with the 40. That means whenever you combine your blocks number, nouns, and your data, your hash should be with the 4 zeros, starting with the 4 zeros, right? So let's start with the single zero. That means if your hash is starting with a single zero, that means your system is less secure and it can be easily break. So, and it can be easily solved, right? So what that means is, for example, for this data and this block number, what should be a number? Okay, what should be the number whenever these all are combined? It should produce a hash, and that hash has to be starting with a single zero. Okay, so let's manually try with this number 1. It's still invalid. 2, it's still invalid. 3, 4, 5. So when I go from 0 to 5, and this digit 5 makes the block signed and it's said valid, and you can see that your hash is also starting with the single zero. Okay, so this is what miners do. So what is actually the mining means? Mining is nothing, simply they just find this number. So what will be the number, so that whenever they combines with these numbers and the data, that hash will be according to the protocols. And for a real blockchain protocols in a Bitcoin, it should start with the 4 zeros. Okay, so if I keep on trying with the different number, it can take like whole day if I do manually, but if I press a mine, so it's going to manually calculate and find me that 13,256. So these numbers, when combined with this data and this block number, it produces a hash, and this hash is starting with the 4 zeros. Okay, so this is all about mining. So what mining is nothing, they have like a huge computational power to solve or to combine this all data and find what will be the number. Okay, what will be the nouns. So finding a nouns is mining. Okay, so the nouns is incremented until a valid hash is found. Okay, valid hash must start with the 4 zeros currently difficulty. So for blockchains, if you keep on increasing, it's become very complex. For example, if you have like 2 zeros, starting with the 2 zeros, then you see like it's solved in 1 millisecond, and your hash is starting with the 00. And if you make it the 3 zeros, and you can see it took like 264 milliseconds, so it's taking more time, right? So if you go to the 4 zeros, it's take like 538 milliseconds, and if you go to the 5 zeros, it can take a longer, and I think my PC cannot solve this. Okay, so this is all about proof of work and a single block. So what does a block contains? It contains a block number, what will be the random numbers when combined with the data, and the block number that will produce the hash, and that hash must start with the required number of zeros, and that numbers is defined in the protocol of the blockchain. Okay, now let's understand here in let's understand about the blockchain. So how these blocks are linked together so that it becomes immutable and tampering of data becomes impossible. So this is block 1. So right now all blocks are invalid, and this is the first block. So first block is known as a genesis block, that is its previous hash will be all set to 0. So this is the starting block, and if I press mine, because this is 50, so let me reduce to single or 00, so it will be easier, right? So if I press a mine, and it easily solved with this number, that this is now a valid and signed block, and it produces a hash, right? And in a block 2, what happens is if I press a mine, and it has some data like Alice space Bob's 10 BTC, and the new features is in a blockchains they have like a previous hash. So this block 2 is linked to the block 1 using a previous hash, right? So whatever the data here, they produces a hash, and this hash is being used in this hash. Now block 2 contains previous hash, data, nouns, block number. When these all things data are combined, and it produces a new hash. Okay, this is the hash from the block 2, and this hash is being used in the block 3, right? And this hash produced in the block 3 is linked to the block 4, and like that. So every block, new block is linked to the subsequent new block, right, in a blockchain. So what happens is if I make anything changes here, like Alice space Bob to 10 BTC to 100, so what happened is immediately the blocks where I made changes, that block and the subsequent all the blocks after that blocks, everything becomes invalid, right? Because whenever I made changes here, this made changes to the new hash, and this new hash is being used here. So this new hash is not matched with the previous hash, right? So now it produces another new hash here in block 2, and this hash is being used as a previous hash in block 4. The previous hash used in the block 4 was different than this one, so this become also invalid, right? Like that, every block after this block 2, they all become invalid, but block 1 is still green because there is nothing changed, so it is same. But after block 2, everything, because there is some problems here in block 2, so every subsequent blocks are invalid, right? This is how it protects, it makes blockchains tamper evident and immutable. So what can be done here? So if I want to change from previously it was like 10 BTC, and if I want to make it like 100 BTC, if I hack the system and change this 10 to 100 BTC, and if I do again a mining, right, now everything seems valid, right? Every blocks are valid, but actually I had changed the data, right? So how we can prevent this one? Then after we have the concept of distributed system. Rather than having a single node, we're going to distribute the copy of lasers to the different peers. So this one is a peer A, this one is peer B, peer C, like that. Okay, so same laser is being copied to copy to different users. For in a bank, what happens is whenever any changes is made, they only update their one server, right? But in a distributed system, that changes has to be made to the every node. So every peer A, peer B, peer C, everyone has to be updated, and every laser has to be same. Okay, so let's understand this one. So let me mine this one, this two, this also, and this three. Now you see that all peers are in consens. That means everything is fair, everything is healthy, the whole network is healthy because there is nothing changes. And how we can notice that one? We need to check the last block, right? If anything happens or any tempering is done in the previous block, everything can be noticed from the last hash. So if you check the last hash, it is starting with ending with the E57. This one also E57, right? So all the hash of the last blocks are same. That means nothing has been tempered before this block, right? So the system is healthy. Now what I do, I make changes like 100 here. That means this change become invalid, right? And this block is also invalid, and every subsequent block after this blocks becomes invalid. So what I can do is I can change, I already changed here from 10 to 100 BTC. Then after everything is valid according to the network, right? Blockchain protocol, right? So I made changes here in the data, and it's starting with the 000. Every hash is 000. Every background is green, and it's showing valid, and the chain is also valid, right? If I do the mining, but our network is showing that network has diverged. Why? Because every peers are valid. See, every peer A, B, C, all are having a valid chain, but our network is saying that there is a diverse. Why? Let's check the last hash. So it is ending with the 6AC, and it is with a different 79F, and this one is also 79F. That means this block A, that means in a peer A, there is something is wrong. Although it's showing the valid change, there is some changes. Because of these changes, this hash is different, and this hash also different, and this hash also different. So when the last hash is checked by the system, it is found that this hash is different than this two. So this two agree and this one disagree. So that means something is wrong with this PRA. Then after they will remove this PRA because he has done something hacking or tampering in the data, right? Then after only PRB and PRC will be in functioning. And this is how they makes tempering practical impossible. Let's understand about the meme pool. So what is a meme pool? That is a memory pool. In a blockchain, whenever any transaction is made, they are not immediately solved or recorded in a blockchain. What they need to be done is they has to be first picked by the miners, and they need to find or they need to be solved, and then after only they are recorded in a blockchain history. Okay, so this is how meme pool works. For example, there are like multiple transactions. First they will be in a pending or waiting room like this, and the miners will pick this transaction based upon the priority. If the users is paying high gas fee, those high gas fees transaction are picked at first. Then after others transaction are picked randomly by the miners. So this is all about randomly picked. There is no any rules or any order for picking all the transaction. So this is how miners take all the transaction, and they put all the transaction and they do the mining, and now this block is solved. That means all these transactions are solved, and they are sent, or they are now can be recorded in a blockchain history. What is tokens? So we have seen like here just random data like hello blockchains or some random text, but in real blockchains we are not recording any random text, but we are storing the real transaction like this. So $25 sent by Bob to the Ross, and $8 sent by Charlie to Jane. So we are transferring from text to some monetary transaction. So we are storing the monetary transaction here in as a data in blockchain. Okay, so this is now a valid blockchain, right? If I do the mining, okay. Now the problems here is $25 has been sent by the Bob to the Ross. So two things you need to understand in the blockchains. One is you cannot temper, or you can go to the past and temper the data, or you cannot change and make any changes in the data, because if you make changes in the data, it can be easily notified with the hash. Okay, that is the first thing. We don't want any changes in our data. Our system should be immutable, right? That is the first thing. And next thing is, every transaction has to be logically valid. That means if $25 has need to be sent by Bob to the Ross, does Bob really have $25? How we can check whether Bob has really $25 or not? Okay, that is the thing we need to understand. So let's try to understand with this Coinbase transactions. Coinbase transaction is special reward given to the miners. It is the genesis of all money. That means I'll just show you with the real examples. Coin market, if you see here in Bitcoin, so whenever this Bitcoin smart contract was deployed, and it has clearly mentioned that the maximum supply will be 21 million, so it cannot be more or less than that. Right now 19.97 million Bitcoin has been circulated to people's or miners wallet already. That means now only 1.03 millions is remaining to be mined. Okay, so how those 1.03 million will be circulated to the wallet, it is depend upon it is given as a rewards to the miners when they solve any transaction, right? So that means whenever this persons, that is Bob, he solved some puzzles here in the blockchains, he will be rewarded as $100. That is directly given from the blockchain contract to this Bob wallet. Okay, now Bob has how much? $100, right? That is, this Bob cannot get this $25 from anywhere. Okay, from randomly he cannot get this $25 randomly, but it has to be given from the, it has to be received as a mining reward by the Bob. Now Bob has how much? $100. Now he sent, like Bob sent $25 to Ross, $20, $10 to Jane, $10 to James, right? How much he has spent? 25 to 35, 45. Now total $45 has been spent by the Bob, and he has remaining of $55. Okay, this is a valid because logically it is correct, right? He has $100. Now he can spend $45. This block is still in, not solved, and it's showing that $10 is given by Ross to Jack, like that. Okay, if I press mine, this is valid. Okay, how much Ross gave? Only $10 Ross gave. Ross has how much? $100, right? And also $25 also given by Bob to the Ross. So altogether Ross has how much? 1 to 5, right? If you solve like this, every block, everything is valid, right? It's checking. Now $5 is given by Collins to the Bob. Can he give $5? Yes, because he already has $100 given as a reward from the mining. Okay, $5 from by the James to Collins. Does James really have $5? Here $100 is given to Jack. No, he doesn't have $5. And if you check the previous hash, and here he can find that $5 is given by Jane to James. Okay, $5 is given by Jane to James. That means $5 can be given by James to the Collins, right? This is how every blocks are linked, and we can easily find like who is having how much. But in bank we just have like every person has, this person has this much, or for example person A or Bob has $25,000 in his account. They store like that. But in blockchains they only record the transaction, not they don't record like Bob has this much of amount. Okay, it's depend, they just track back all the history to find out how much Bob has and how much he can give. One thing I can show you here, like how much Bob has, $100, right? And what if Bob wants to give $205 to the Ross? Can he? No, because he has only $100, right? He cannot spend $205. This $10, 200 means $225. He cannot spend $225 because he can only spend $100. Okay, he only owned $100 from the mining reward. So this becomes insufficient fund and it's invalid, right? So this is all about blockchains. Thank you so much for watching.